All right, so we just did an example of finding an inverse if it was a set of ordered pairs, right? So now what if it's a actual algebraic function? How do you find an equation of how do you find the equation of the inverse function? And here's the process. For a one-to-one function, that's huge. First and foremost, the function has to be one-to-one. The equation of the inverse can be found as follows. Replace f of x by y. Switch the x's and y's. Solve for y. Once you do, replace y with f inverse and you're finished. What did you do when you had a set of ordered pairs? What did you do to the x's and y's? You switched them, right? You can do the same thing here. Okay, given f, find f inverse. Okay, the process says, instead of writing f of x, write y. Y equals 2x plus 5. What was the next step? Switch x's and y's. Anywhere you see a y, write an x. Anywhere you see an x, write a y. Now go solve for y. How? Subtract 5 from both sides. So I have x minus 5 equals 2y. Divide both sides by 2. I get x minus 5 all over 2 is equal to y. Then the last step says replace y with f inverse, right? Right here? Okay, if I graph f and f inverse on the same axes, this is what I get. Okay, I'm going to look at f in red. F is graphed right here. Y equals 2x plus 5. F inverse, I'm going to do in purple. Y equals x minus 5 all over 2 is down here. I graphed that on my calculator. Something I want you to notice, do you see that yellow line, y equals x? Do you see that the graphs of f and f inverse are symmetric with respect to that line, y equals x? If I have the point, let's say, what would that be? 0, 5 right here? If the point 0, 5 is on f, then the point 5, 0 is on f inverse. You make that with purple. Question?
Is that on the f inverse?
Nope, you have to actually type this in on your calculator. Under y1, you're going to type this. Under y2, you're going to type that. Okay, this point is the point 0, 5 on f. This point on f inverse is the point, what'd you say? 5, 0. That's true for any points on f and f inverse. If you have xy on f, you're going to have yx on f inverse. Let's go do another one. How about x squared plus 2? What does the graph of that look like, first of all? Looks like that, yes? Does that pass the horizontal line test? No. So it's not 1-to-1. So this one does not have an inverse. However, if you chop that piece off, would it be 1 to 1?
Yes.
Yes. So let's go do that. Number 3. So for my f over here on my graph is right here. That one is 1 to 1. Do you agree? All right. So go find the inverse. Okay, first step is to say y equals x squared plus 2. Swap the x's and y's, so x equals y squared plus 2. Now solve for y. I need to subtract 2 from both sides. X minus 2 equals y squared. To solve for y, I need to square root, right? But what happens on this side when I put the square root? I have to put plus or minus out front. So I get plus or minus root x minus 2 is equal to y. Okay, so how many functions are there? There's 2 functions there, right? There's y equals root x minus 2, and there's y equals negative root x minus 2. So which one do you pick? We'll go graph them. Okay, back on your calculator. Your original f, which we did in red, right, was x squared plus 2. But we wanted to restrict the domain. Do you remember how to do that? You say divided by x second test greater than or equal to is number 4, 0. So let's go make sure. Yep, that's what we wanted, right? So now back on your y equals, we want to go graph the square root of x minus 2, and we want to graph negative square root of x minus 2, because those are the 2 that we got right here, right? So when we look at our graph, which one do we want? Do we want the blue one or the pink one? It has to be symmetric over the line y equals x, right? With our red graph. So the blue one would be the mirror image over the line y equals x. Which one was that? That was the positive square root. So our inverse function is the positive square root of x minus 2. Right here. Totally different problem. So this would be like number 3b. If your function was, say, x squared plus 2, but you wanted x less than or equal to 0, what would that look like? That would be over here. You agree? So here's the line y equals x again. Instead of having the point 0, 2, you would want the point 2, 0. Instead of having the point negative 1, 3 here, you would have the point 3, negative 1 down here. So your inverse would look like that. So for this one, f inverse would have been negative root x minus 2. Is that kind of cool? Not really. Who cares? But it all works. It's all good. All right. Number 4. I'm giving you f. You go find f inverse. I'm going to tell you the graph of f is right here. That's f. You're trying to find f inverse. I'm showing you the graph because I want you to make sure that f is 1 to 1. Is it?
Yes.
Yes, it's always increasing. So go find f inverse. Okay, here we go. Instead of writing y equals x minus 2 cubed, I'm going to write x equals y minus 2 cubed. How do I get rid of the cubed? Cubed root of both sides. Do I have to put a plus or minus when I take a cubed root? No, just a square root. Okay, so I get the cubed root of x equals what? Y minus 2. Then what do I want to do to both sides? Add 2 to both sides, so I get the cubed root of x plus 2 is equal to y. So my inverse function is equal to the cubed root of x plus 2. On my graph, f inverse is right here. It looks like the cubed root function, but it's been shifted which way? Up 2. Questions? How do you find, if I give you f, could you go find f inverse? Okay, this one's a little more challenging. Number 5. Why would I do that to you? Okay, on this one, f is orange. F is always decreasing. It has a vertical asymptote where? It has a vertical asymptote at x equals 4. Where does it have a horizontal asymptote? Degree is the same. So y equals 2 over 1. Y equals 2. I'm just telling you that because I'm going to show you in just a second how that relates to f inverse. Okay, here we go. Y equals 2x plus 3 over x minus 4. Switch the x's and y's. X equals 2y plus 3 over y minus 4. You're trying to get y by itself. Let's get rid of the denominator by multiplying both sides by y minus 4. Good. Y minus 4, y minus 4. Those are gone. On the left, is it okay to distribute? So you get xy minus 4x is equal to 2y plus 3. Okay, the goal again is to get y by itself. We need to get everything with a y on one side. So let's get this one over to this side. How? Subtract it. That'll be gone. I'll have xy minus 2y minus 4x equal to 3. Three more steps. What's the next step? Not yet. You got to get that 4x over to the right. Add 4x to both sides. So you have xy minus 2y is equal to 4x plus 3. Both of the things on the left have a y in them, right? Factor it out. If I factor out a y, I'm left with just x minus 2, exactly. Now what can I divide both sides by? X minus 2. And I'm left with y equals 4x plus 3 over x minus 2. That is my inverse function. For my inverse function, what is my vertical asymptote? X equals 2. What is my horizontal asymptote? Y equals 4. Okay, for my inverse, my horizontal asymptote is y equals 4. For my function, my vertical asymptote was x equals 4. Functions and their inverses, you switch x's and y's, right? So vertical asymptote x equals 4 becomes a horizontal asymptote y equals 4. On my function, the horizontal asymptote y equals 2. For the inverse, I'm going to switch it, and it becomes x equals 2. Okay, so my function, what was my vertical at x equals 4, horizontal at y equals 2? For my inverse, I had a vertical at x equal 2 and horizontal at y equal 4. Do you agree? That's what we just wrote out up on the page above. So right here, the vertical asymptote at x equal 4 became a horizontal asymptote at y equal 4 on my inverse. For my original function, I had a horizontal at y equal 2. What did that become on my inverse? A vertical at x equal 2. Do you see how the line y equal x, there's symmetry across it? This point here at what, 2, 4? The intersection of the vertical and horizontal asymptote is here at 4, 2. The big thing you're supposed to get on functions and their inverses is that they switch the x's and y's. That's the big take-home message here. And I know that this is a very messy graph, but do you see the symmetry? Look at just this little piece down here. It's symmetric over that line y equal x. Okay, the last green says F inverse is a reflection of F over the line y equal x.